Thank you. Thank you for that reminder. Okay, so to update, open up a terminal window in your directory here. Let me make this bigger. Okay, and what you're going to type in is git fetch upstream. All right, so that fetches the upstream changes. And then, and I'm already on master branch, so I don't need to check out master. And I'm going to just do git merge upstream master. Okay, and we can see that it has updated these two files, 0202 IPyNB and 0202 slides IPyNB, and then we're going to go ahead and push these to my own remote repository. And so this will go to your own remote repository, and that's all you have to do. Okay, so just those 3 commands, and you'll get all of the new files that I've uploaded or pushed to my own class repository, and you can do that pretty much every time I do a new lecture. I'll probably have some new files up there, and that's all you have to do to get your repository in sync with mine. Okay, is that good? Is it not working for anybody? All right, so I'm going to go back to my computer, and let's go ahead and open up these slides. Let me actually, I have my Jupyter notebook running here, and let me also open up the slides themselves here. Okay, so here it is as a slideshow. All right, and here, let me see. Can I? Is it on my face now? I think. Okay. It's not showing the screen, right? Yeah. Okay. So I think it's showing my face. So this is the textbook. Think Python. It's free online. The author made a PDF version of his textbook free. It's a very good textbook, and it covers. Gives you basically intro programming and whatnot. Anyway, read it, and if you're coming, this class only assumes you've taken Stats 20, and so you probably learned a lot of these basic things here, but we're going to do some of the stuff in Python, and even if you some of this is review. I think it's good content. Let me go back to sharing my screen here. And so, so I believe I've linked to the page, but you can just type in Think Python, all right? And the first link on Google should be Think Python 2nd edition under Green Tea Press, and you can just download the textbook in PDF form. All right, and of course, if you want the print book, you can spend the money and buy it at Amazon, and it currently costs $40 to buy the print version, but download the PDF, and it's pretty good. Okay, so so please be sure you keep up with the reading. One of the reasons why I've chosen this book is that it is very concise. Okay. All right, so chapter 1 is like 8 pages long. Okay, chapter 2 is another 8 pages long. Each of these chapters is very quick. The author doesn't waste any of his words, so read it, and rather than being overwhelmed with like 50 pages, just read a handful of them. Okay, and yeah, and everything this guy says is pretty good stuff. Okay. And I've added a little bit here. Okay, so so this is one key idea, is that basically all programs that are out there can be reduced to just one of these 5 things. Okay, getting input either from a keyboard, file network, or some other kind of device, mouse or whatever. Okay, output, which is either display data to the screen, save to a file, send over a network, something. Okay, math, which is to perform some kind of mathematical operation. And then you've got conditional execution, check for certain conditions and run the appropriate code. And you also have repetition, which is repeat some action repeatedly, usually with some variation. Even video games, okay? Video games can all be reduced to this. So if you think of like just a simple two-dimensional platformer video game like Mario Brothers or something, okay? And the input comes from the video game controller, all right? The output is what each pixel on the screen, what color that pixel on the screen should be. And then the math is where all the work is done, right? If you know, the longer you hold down a button, it's gonna move the basically the internal position of the character to the right, and then that gets reflected on the screen. When you push the jump button, it does mathematical calculations to figure out exactly kind of the position and all of that. All right, and then conditional execution for like if the character, if a hitbox hits another hitbox, you know, your character gets injured and things like that. So that's pretty much all programs, all games, everything can be reduced to these kinds of operations. You know, as we work in Python, there are going to be different data types, okay? And probably the most commonly used ones as far as the base types go will be strings, integers, floats, and Booleans, okay? So strings is everything for text data, okay? Anything, they're gonna always be wrapped around in quotes. Integers, you know, whole numbers and negative whole numbers. Floating point numbers are anything with a decimal, and they are stored in, you know, double precision format. In Python, you can specify whether you want, you can also specify you want single precision and things like that, but by default, it's gonna be a double precision floating point number, which means it uses 64 bits, and you know, I haven't gotten into floating point arithmetic here, but there are limitations to floating point numbers, okay? There's no such thing as a real number in a computer, okay? A real number has potentially infinitely many decimal places behind it, okay? Like pi goes on, is known for having infinitely many decimal places, and there's no way to store infinitely many values on a computer with limited storage and resources, right? There's no way even to store infinitely many values as we know it in the universe, right? Because the universe, as far as we know, I think is finite. There's a finite amount of matter, and so there's only going to be a finite number of ways to represent information. So you cannot store all the digits of pi. It's not even possible to represent them. Even if you dedicated all the matter that currently exists in the universe to displaying pi, it's not possible because there's a finite amount and there's infinitely many digits in pi. So it's just not going to happen. Okay, anyway, that was a bit of a tangent there. And we have Boolean values. And Boolean values are true and false values, okay? So other things, and we will encounter these, will be lists and tuples and ranges. We also have dictionaries and sets and binary things such as bytes. There's even more kinds of different data types in Python. These are probably going to be the ones that we encounter. But there's even more, and you can always just go on the internet and search for Python types. Okay, so let me just show you. You can ask what is the type of data that you have, and you just type in type. Okay, you call type on a number, and it will say it is. So here's the number 2, and we say type on the number, and it tells you it is an integer, okay? And if you type in the number 2.0, then Python tells you that's a float, okay? So you got ints and you got floats. So we have a float here. If you put quotes around the number 2, Python will tell you it's a string. Okay, so no surprises here. No surprises here. Is a function a data type? Yeah, it'll be a function. So yeah, everything has a. So here is the actual notebook. If I just kind of scroll to the bottom here, and okay, and so here I've got. Let's see, what's a what's a basic function that that I can do here, such as okay, so sorted is a function here, and if I just say type on this, okay, it will say it is it's a built-in function or method. Okay, so so everything in Python is an object, and you can always find out what kind of type the function is, or I guess what kind of object. All right, and so when you do math with numbers in Python, it generally tries to preserve the types. Like if you're dealing with integers, it'll generally keep it as integers, but you know, with some exceptions here. Okay, so here I've got x and I've got y. X is 10, y is 5. And if I ask what's the type of x and what's the type of y, Python returns or prints out that it's a class integer and class integer here. Okay. Notice when here the output is int, but then when you ask for a print, it actually prints out a little bit different here. Okay. And if I do x plus y, then we're going to get 15, and the type is still an integer. Okay. If I do multiplication, same thing, 10 and 5, what is x times y? X times y is 50, and that's an int. Okay. Over here, I've got division is always going to result in a float. So I've got 10 and 5, and if I do 10 divided by 5, Python tells me it's a float. Okay. So 10 divided by 5, even though 10 divided by 5 is 2, division is always going to result in a floating point. And so 10 divided by 5 is 2.0. Okay, so that's just that's there. And one nice thing about Python is that whenever it's an integer, there will be no decimal places. Okay, it will just say 50, or and there's no 0.0. And anytime it's a float, okay, anytime it's a float, it will always put in a point here. Okay, so so it will say, you know, this is 2.0. Okay, so let me just kind of show you an example here. If I type in 10.0, then Python knows that this is going to be a float. So x is 10.0, and if I ask what is the type of x, Python tells me it is float data type. Okay, and y is an integer, and if I ask what is the type on y, Python tells me it's an integer. And if I take the sum or the product of these, okay, if I say what is 10.0 plus 5, it returns 15.0. So we know just by looking at this that this is a float. Okay, and what is x times y? 10.0 times 5 will be 50.0. Okay, and so we know that this is also a float. Okay, which is nice. You know what? I want to add a few more things here. Okay, I just thought of this. Where am I? Okay, so here I am. So an interesting thing is that so floating point numbers on your computer have a maximum upper limit. Okay, so if I do 2.0 and raise it to the 1023, okay, oops, silly me. The exponent power thing is two stars. Okay, so I can do 2.0 times 10 to the 23, and that will give me a result. 2.0 to the 1024, however, will result in an overflow error. Okay, it says result too big. Okay, and so you can do 2.0 times 10 to the 23, and you can do 2.0 plus 2.0 to the 1022 plus 2.0 to the 1021, and you're going to get quite a big number. But if you try to do 2.0 to 10 to the 24, you're going to get an overflow error. Okay, and that's because in floating point arithmetic, okay, you have 64 bits to store your number, and this value, this is too big to be represented with 64 bits in floating point, I guess in double floating point. All right. However, integers, on the other hand, this is an interesting thing about Python, is that integers are not, they take up variable amounts of space in memory in Python, okay? This is different from R. In R, there's an integer max value that you have. So in, so if I do 2 raised to the 1023, it gives me a big number. And if I did it in floating point, okay, it gives me 8.9, and it really only goes out to maybe about 15, 16 decimal places, okay? After the 15th or 16th decimal place, it's no longer accurate, okay? But here with Python, you get all of the decimal places, okay? They are all there. And I can do 2 to the 1024, and this will not break my computer, okay? I can do 2 to the 1025, all right? And this all works, okay? So that's an interesting thing, okay? So integers in Python. Let me switch this, okay? So I'll just write integers in Python use variable amounts of memory. So it's taking quite a bit of memory and not very much, okay? Use variable amounts of memory and can have very and can show very large numbers with great precision. All right. I can't see your faces, so I can't tell if you guys are impressed, but you should be impressed by this feat. Okay, this is okay. With floating point numbers, you've got a limit. You've got a hard limit around 10 to the 308th power, and with Python, look at this. This is incredible. Okay, but all right. Okay, all right. Thanks for that thumbs up. I appreciate it. Okay, so so anyway, that's what we got here. I got to I'm gonna have to update my slides here to include this. Restart and run all. And where did where's my note? There it is. Okay, so this is what I want to do. Let me close this out. Sorry. Let's convert everything to slides, and here we go. All right, so here we go. We got this, but now we have this, which is amazing. And okay, so so there you got integers. All right, and again, the difference here is I've got 2, which indicates it's an integer, whereas over here I write 2.0, so that makes it kind of pushes Python into a floating point arithmetic here. Okay, Booleans. Booleans are basically your true-false values. Okay, and the way we write true in Python is capital T, lowercase r-u-e. Now I guess I got to modify my my slides here. Also, let me just show you what happens if you try typing in true in a different way. Okay, so this takes a little bit of getting used to if you're coming from a different language like R. Okay, so if you type in capital T-R-U-E, this is going to result in an error. Okay, it's going to say I don't know what you're talking about. Okay, true is capital T, lowercase r-u-e. Okay, and if you just do capital T, that's not defined. So capital T is not defined, lowercase t is not defined, only capital T, lowercase r-u-e, all right? And capital F, lowercase a-l-s-e for false, okay? The other things will not work, okay? So true or t or little true, that's not going to work. Okay, if Jupyter takes on properties of R, no, Jupyter does not take on properties of R, okay? Jupyter is just this web thing, okay? It's just an interactive screen that we can use. It's an interactive screen that we can use, and we can say use Python to run all the computations or use R to run all the computations, but they are completely separate languages. You can't be mixing Python and R together on in a notebook like this. Okay, so so this is the Python language. You have to use capital T, lowercase r-u-e. The other stuff will not work. Okay, capital F, lowercase the rest of the letters. Okay, we've got math operations in Python, okay? So in base Python, okay, regular old Python, when you start off, it only supports a few math operations. So you can do addition, multiplication, subtraction, division. You can do integer division and remainders, and you can raise to the power, and you can take absolute values. That's about it. That's about it for math operations, okay? So you guys are already familiar with this kind of stuff, addition, multiplication, subtraction. But let me just show you what integer division is. So 8 divided by 3 is 2 2/3, 2.6666, whatnot, okay? 8 double/3 is going to be basically how many whole number of times does 3 go into 8? And it goes into 8 2 times, okay? And the result of this, what is the data type of this result when you do integer division? It's an integer, okay? So the result of 8 double/3 is an integer, and we know it's an integer because Python doesn't show us a 0.0 or anything like that, okay? And then if you do 8% 3, you know what? This was not the best example, I realize. Okay, I should have done 7 divided by 3. Okay, this will be the remainder, okay? All right, so let me, so 7 divided by 3 will give me 2 1/3. Oops, what the heck? And then 7 double/3 will give me 2. 7% 3 will give me 1, okay? And so that's what we have there, okay? So this is how many times does 3 go into 7? And it goes into 7 twice. And this is what's the remainder if you do that, okay? Then there will be 1 left over. Exponentiation, 9 squared is 81. There's no square root function in Python, okay? And this might be surprising. You can't take square roots in Python. So if you try to do square root of 9, it's going to give you an error. It's going to say square root is not defined, okay? Which might be surprising. You feel like square root is such a basic function. But you have exponentiation, so you can always do 9 raised to the 1/2 power, and that will give you a square root. Okay, so that could work. But yeah, you don't have a square root function. If you try to do operations with something like pi, that's not defined. If you try to raise exponent like e to the 2, that's not defined. If you try to do a sine function, that's also not defined. None of these things are defined in base Python. So, so these are all going to return errors of basically not defined. Somebody, let me just mute you. Okay. So if you want to do any kind of basic math operations, you need to import what's known as the math module. Okay. So you can either import math, the Numpy module. There's different modules that contain a lot of math functions. Okay. So if you want to do math, you have to run import math. Okay. And if you do import math, then you can run math.square root. Okay. Math.square root of 9. And that returns 3.0. So this is a float. The result of the square root of 9 is a float. Math.pi, it gives us an approximation of pi, 3.14159. And then math.exp will do e to this second power or whatever it is that you're trying to do. You can do that. So these are all available, right? And then, or math.sine, you can do math.sine of math.pi divided by 2. Okay, so sine of pi halves is 1.0, and the math function uses, the sine function in the math module uses radians, okay? And again, if you try to do just math.sine and you just write pi, it's gonna return an error because it doesn't know what pi is. But you can say math.pi, and then Python will know that we're talking about the pi function, or pi value constant that exists inside the math module. So there's a lot of things. I think, if you're coming from R, you're accustomed to a lot of these functions being available in the base version of R, and they're not there in Python. I mean, when you install Python, the math module is automatically installed, but you have to import it. You have to import it. Okay, and one of the reasons why is because some people don't always, not everybody uses these math functions. And so to kind of speed things up and reduce the amount of overhead as far as what functions exist inside memory and things like that, they make it, okay. Yeah, would you do numpy.square root if you imported numpy? Yes, absolutely. So if you would write import numpy, and you would write numpy.square root, okay? And yeah, and that's that. So I mean, you can go on Google and you can type in numpy square root, right? And it's gonna look exactly just as you've written, okay? Numpy.square root, okay? Numpy.square root. And almost everyone, when they import NumPy, they're gonna import NumPy as NP, and which just will save people a couple keystrokes of typing. So instead of having to type out NumPy every time, they type in NP. They'll import NumPy as NP. That's kind of a thing, and so you will often see NP.square root to kind of do it. And the nice thing about the NumPy function is you can take square roots of like an entire array. Okay, the NumPy functions are vectorized, and we'll have to cover that later. Right? Okay, let's talk about assignment. Okay, I think you guys are already all familiar with assignment, but in Python you do it with an equal sign. All right, and so in R you have to use the arrow, the less than dash. In Python it's equals, and sometimes when you switch back and forth, your brain makes mistakes, and you try. So luckily in R you can use equal sign for assignment, but in Python it's only equal sign. If you try to use the arrow thing, it's not going to work. Okay, the names always have to be on the left-hand side, and the value you are assigning always goes on the right-hand side. Okay, and just like R, just like pretty much other languages, when you do an assignment operation, it's not going to output anything onto the screen. It's just going to assign it and do it quietly that when you do that assignment statement. Okay, so here's n equals 5. When you run it, it's not going to output anything to the screen. There's no out associated with this input cell, n equals 5. But, oh, I didn't start a new slide. Okay, but when you say print n, it's going to output the number 5 onto the screen. Okay, as far as variable names go, all right, you can choose almost anything you want to be a variable name, right? There's a few rules. Okay, names can have letters, numbers, and underscore characters, okay? Names cannot start with a number. Names can't have symbols other than the underscore, no spaces in the name, and you can't use a keyword, okay? Python keyword, right? And so the Python keywords are this, and these are, I think, you know, you might not be familiar with all of them, but here they are, okay? We're gonna use a lot of these things, and so you're not gonna be surprised, okay? Most of the keywords are all lowercase, okay? With the exception of false, none, and true. Those are the only keywords that have a capital letter. Everything else is pretty much lowercase. All right, so I wanna spend a little bit of time talking about naming variables, okay? There's a quote that says, the only thing difficult in computer programming, I forget what it was, is something, you know, something ridiculously hard, and naming variables. and it's true. It's hard. It's hard to think of good variable names, okay? And so, you know, the goal that you want to keep in mind is that if you go back and read your old code from like 6 months ago, can you figure out what the code is doing right away, right? Is there enough information in basically plain English without having to read all the comments? Is there enough information in plain English for you to understand what this code is doing? And if you name all of your variables X, Y, Z, or single letter things, there's not going to be enough information there. If you use more descriptive names that are basically English words, then it's helpful, okay? And so there's a couple web pages that I used. All right, so this is talking about variable naming, and I used some of the principles there, and these are good principles. Be clear and concise when you name your variables. The variable names should be English, which I know is very ethnocentric, but that's kind of the standard practice from around the world. And then, so if you're, you know, speaker of a foreign language, still try to write your names in English. And then, and they shouldn't contain any special characters. So you can have, you know, like if you are in Germany or something, you can have these characters with the double dots, the umlauts over the vowels, but you shouldn't use those as far as Python variable names go. Okay, just stick to your US or US keyboard and the symbols there. Those are all ASCII allowed keys. So just basically the letters, lowercase, capital, the numbers, and the underscore. Okay, so here's an examples of variable names that are not great. Okay, you got S is equal to 101533. Or SID is 101533. Okay, so okay, you go SID. Well, maybe it's some kind of identification number, but it's not enough, right? We have no idea what they represent. Okay, and then the flip side of this is writing a variable name that is so long that no one's gonna want to have to write this out, right? So we can write Finnish Meteorological Institute Observation Station Identification Number. Okay. Now we go, oh, okay, that's what this thing was trying to represent. But first of all, this is like really difficult to read, okay? But that, and it's also way too long, okay? And if you have operations that make use of this variable, it's suddenly your operation lines are gonna have to be on like 6 different lines because each variable just takes up one line. So that's not gonna be good, right? Too long and difficult to read. So there's a couple naming conventions that allow us to kind of combine words, and there's a few basically you have snake case, which uses underscores between words, okay? So everything's lowercase with underscores in between words, or you use camel case, okay? Camel case means you use a capital letter, no underscores, but capital letters to indicate differences between words, okay? So you generally want to pick one or the other, okay? And there's lower camel case where the first letter is lowercase, and upper camel case where the first letter is uppercase, okay? And so some options that are better, it will be FMI station ID, okay? And so this is short and concise, and it clearly indicates what it is. Or, so this is snake case, and this is camel case, all right? I guess I forgot to do that, okay? All right, there's other naming considerations that are good, okay? If you are going to create a list or an array, the name of the list, it's helpful if the name of the list is a plural, okay? Because then you go, oh, it's not going to be a single thing, it's not going to be a single object, but there's going to be multiple things in there, right? And if the variable contains string values, then including the word names in there is also useful. Sorry, this should have been on a new slide. Okay. Okay. So for example, here's a list, and it's got the values apple, banana, and orange. Okay, so this is a list. So there's 3 values in here. And if you just called it fruit, yeah, it's not great. Okay, but if you indicate that it's fruits, you know, this is much better. Okay, because it's plural, and so we know. Okay, well, this is going to be a list that contains more than one fruit in it. Okay, maybe even better is fruit names. Fruit names has the word names in it, and so now we know, or it should be an indicator to the person reading the code that this is going to include string text. Because remember, the point is as you're using this variable name, okay, you're not going to necessarily see the operation where the assignment was done. And so if you encounter this variable name fruit names all by itself, can you recall what's going to be contained inside the variable? Okay, and with something like fruit names, that's helpful. Whereas fruit all by itself is not as useful. Okay, Boolean values. Boolean values. The names for Boolean values are best when they are in the form of a question that can be answered with a yes or a no. Okay, so for example, these are not great Boolean value names. Selected, right, and fruit. These are not great. But you just add a short word in front, such as is selected. Now it's very clear that this is going to be either a true or false, you know, a yes or no answer, right? Can write, meaning can this value be written or whatever, true or false. Has fruit, does this value or array or something contain fruit or something, and has fruit, the answer to that question is going to be you know, a true or false. And so Boolean values are often useful if you've got if they're written in short little question forms or something like this. Okay, you know, these are all kind of opinions, and you know, people are going to have different opinions on the subject, but I think these are some good guiding principles. Okay, just things to think about as you write your programs and your functions, and you want to try to get into the habit of writing good variable names early, and it does require some mental energy. Okay. As far as numeric values go, adding a describing word can be useful, right? So if you just have rows equals 3, it's a little bit unclear. Okay, so we go, okay, well, rows, this is associated with rows. Here's some different ideas that you can use, right? You can use minimum number of rows, min rows, max rows, total rows, current row. These are all different options as far as naming a numeric variable, okay? And these are, I think, a little bit more descriptive, and we'll get a sense of what these values signify, okay? Function names, okay? When you name a function, also, how you name the function is important, right? So if a function that modifies, if there's a function that's going to modify an object, functions should generally take on action verbs, okay? And so here, if you have a function that will take a list and modify it by sorting it, it should be called sort. The sort is going to actually modify the list. On the other hand, there could be another function that sorts the list but doesn't modify it, right? It returns a copy that's sorted, but doesn't modify the list itself, okay? And we'll get into this concept of modifying objects in place. And this is going to be known as, should be called sorted. So there's a difference between sort and sorted, right? Give me a sorted version of the list versus actually sort the list. So there's a difference. And so luckily for us, Python implements a lot of these good practices. Oh, you know what? I realized I haven't given you the quiz answers. Okay, quiz answers today. First question is A as in apple, and second question is B as in boy, okay? So A as in apple for the first question, B as in boy for the second question, okay? Did we all get that there? Okay. A as in apple for the first question, B as in boy for the second question. Okay, so here's an example, all right? I have a list here called car brand names, okay? And we've got Ford, BMW, Volvo, Toyota, all right? And here, I run this function, car brand names.sort, okay? So this function sorts and modifies the list itself, okay? And so later on when I ask what is inside car brand names, it is now this list sorted, BMW, Ford, Toyota, Volvo, okay? Over here, I have another list, Chevrolet, Audi, Honda, okay, car brand names. And here I'm going to call sorted on car brand names, okay? Sorted here returns a sorted version, a sorted copy of the list, okay? But it doesn't actually, it doesn't actually change the list itself. Car brand names remains in its original form, Chevrolet, Audi, and Honda, okay? So sorted returns basically a sorted copy, a sorted version of the list, but leaves the original list unchanged. Whereas over here, here's the original list, and this is the result. So let me see, does sort actually work? So I got car. So I'm pretty sure there's no, let me see. So here is, gotta run this. Okay, so here is this, and we'll do car brand names dot sorted. So there's no attribute sorted, so that doesn't actually exist. And let me see what car, I'm trying to think. Car brand names. Yeah, there's no function sort either, okay? So sorted is a standalone function that doesn't modify it itself. Technically, and we'll get into this, okay? Sort is technically a method of the list, and we'll talk about what that means. And sorted is a function, but it doesn't modify the list itself, okay? And so yeah, if you tried car brand names.sorted, that attribute doesn't exist. And if you try running a function called sort on car brand names, that function actually doesn't exist, okay? And so, so yeah, our Python takes care in naming its functions and its methods and returns different things. And so, so these would not work because they are not defined, because Python kind of took care to in how it named its things. And we'll talk about the difference between having a function that is dot something and having a function that kind of is not associated like that, okay? And so, you know, I'm skipping a little bit ahead in terms of topics, but we'll get around, and this is all just kind of related to this idea of variable naming here. Okay, start your reading. I'm going to post up a homework assignment, and this first homework assignment should be fairly basic and simple, and so start with that. You also have a little bit of homework on data camp to do. Most of you guys, almost everyone, got their Git homework done for data camp. Only a couple of you missed it, and you can still do it as long as you complete it within a week. You'll get credit for being late. After a week, it's going to go in the gradebook as a 0. So, so if you missed the deadline for the data camp, you can still do it. You'll just lose a few points for being late, but not that big of a deal. And then you got kind of your introduction to Python data camp homework, and I'll also post a real actual homework problem homework set as well. Okay, that's it for today. Yes, and once I make all of the final changes to these slides, I'll create a PDF version of the slides for you guys as well. Okay, and again, you can always download and update everything. No, you will submit everything on CCLE, okay? The GitHub thing is mostly for you to be able to get the course content quickly and easily, all right? I know in the beginning, Git feels a little bit cumbersome, but it's gonna be, I think in the long run, much more efficient than me uploading things on CCLE and then you downloading things on CCLE. Especially if we've taken the time to learn Git, we should take advantage of it. It's a good system for this kind of distribution stuff. Okay, we'll end here. Stay safe, stay healthy out there, and we'll see you guys on Friday.
Goodbye.